screws. And in between, we can have a four-way that would either have two black screws on the top, two gold screws on the bottom, or it would have two black screws on one side and two gold screws on the other side. Right? You might have one or the other. They're the same thing. It's the same concept. The only thing that these switches are color coded. These black screws right here are not the common anymore. Can you guys see in the back where it says In and Out? The burger place?
Yeah.
You see it? Okay, so that means input, output. That means that there are wires that are coming in and there are wires that are going out. Does everybody's four-way say in and out? Yeah? Does it say input, output on all of them?
Yeah.
Yeah? Alright. Alright, so here we have a simple three-way system. In this three-way system, we might have some loads. We might have two lights. Okay, so I want to be able to turn on these two lights in two different places. So I use my commons and I either bring power or a switch light. So what would be one of the rules to using a three-way system? You, for the common screw, on one three-way, you take power, and on the second three-way, you take a switch light. That would be one rule for wiring a three-way system. A second rule for wiring a three-way system is that the travelers connect between the switches only. They connect between the switches and they go from screw to screw. So we don't usually splice our travelers. They just go directly from one three-way directly into another three-way, or from one three-way into a four-way. So we don't splice them in any way. We don't cut them, we don't put them together like we would put all our travelers. Like there are some people that will think, okay, let me put them together and let me make two pigtails. We don't do that. They're two individual wires that will go from switch to, they have their switch where they're gonna land. They start on one three-way and they land on the other, so we don't splice them. Now, it doesn't really matter where you take the power. It could be on that switch, or the power can be on this switch. What's going to decide which switch is going to receive the power is how close my power source is to any of the switches. Now, my power source could come up to the lights, my power source could come into this box, or my power source can come into this one. But I need to remember that if my power source comes into this box, then this box right here needs to be connected to the lights. Okay, so I'm gonna say that my power source is coming into this box right here. So I'm gonna bring my home run right here. And this is the symbol for a home run, and I'm going to bring a 14-2. In a 14-2, I have a neutral wire, I have power, and I have my ground. I'm going to go ahead and connect this. It's open walls, so I'm gonna go ahead and bring my power in here, and my power, my black wire that's coming from the panel is gonna come right here into the common. Now, the three-ways have the same concept as our regular switches. The neutrals are not connected in a three-way, because if I connect the neutrals, at some point I will have a short circuit, because the neutral will be closing the circuit with one of the switches. Okay, so the neutral will pass through and they will go up to the light. So if I needed to connect it all the way to the other side, that neutral is gonna pass through and it's gonna splice with the neutral that's coming from here. So from this switch to this switch, I would need my neutral and I would need my two travelers. So then a 14-2 would not be enough. I need a 14-3 because I need an extra wire. So from this switch to this switch, I need to run a 14-3. My neutral is still gonna continue to be neutral, and it's gonna come right here into this box. And I'm going to use the black and the red as my travelers. So one black is gonna connect right here. One red is going to connect right here. And then I'm gonna do the same thing here. The red is gonna connect right here. The black is going to connect right here. My travelers went from screw to screw, right? From one screw into another screw, from one screw into the other screw. The travelers are communication wires. So these are they don't need to communicate with the light. They just need to communicate with each other. Because depending on when I have my three-ways, for example, here I have my three-ways. I want you guys to look at your three-ways and see if you can find there an on and off. Can you see a word that says on and off on your three-ways? It should be in the front, not in the back, because the customer has to see it, right? Does it say on and off?
No.
It won't say on and off because these switches are made to be able to turn on in one place and turn off in another, right? So this one should not say on and off. So if, for example, it looks like a three-way, but it says on and off, then you're getting a single pole switch. Okay, it might look like a three-way, but it will not be a three-way if it says on and off. So this one, this switch will not have a specific position to be on and off. It'll just open and close, open and close. But because it has the travelers and they communicate with each other, now the switches will, if this one turned off the light, this one will turn it on. If this one turns on the light, this one will turn them off. But this one can turn on and off the light as well, and this one can turn on and off the light as well. So they work with each other and they communicate with each other through these wires right here. And this lever that you have will go like this. Here as well. It'll communicate here, it'll connect here, it'll connect here, and it'll connect here. So that's how the lever works. So we're able to check those contacts with the multimeter to be able to see if our switches actually work or not. Now with a four-way, it's a little bit more complex because a four-way, internally, it has an X. But there is a way to be able to figure out if it will communicate with the other switches. Okay, and then here, to finish off my circuit, I need to connect this three-way to those lights. So I'm gonna take a 14-2, and the black that's coming in that 14-2 is going to become my switch leg, and the neutral is going to connect right here. Now we know that in this wire I'm gonna have a green screw, right? And that green screw is gonna connect right here to this green screw with the pigtail. And that one is gonna connect to this green screw with the pigtail all the time, right? That ground screw cannot be ignored ever, but I'm not gonna draw it for the purpose of you guys having a cleaner drawing so that you can see the wires that are most important here in this installation. And then our lights, you guys know how to wire the lights, right? For this light, we're going to bring the switch leg, send the switch leg, connect it to neutral, or to the gold screw, we have a neutral. Through a pigtail, we connect the neutral, and the last light is just gonna receive the neutral, and it's going to receive the power. And that will allow my two lights to turn on and off in two different places. And this is just one way of wiring a three-way switch, because there are many, many ways. It all depends on where your power is coming from.
Can you repeat the whole thing?
The 15 amp, your power is gonna come into your receptacle first. Then from that receptacle, you're gonna go into a single pole switch. Your single pole switch has 2 screws. And then from that, you're gonna go into a light. Your light usually has 4 screws. 2 screws are connected, 2 screws are connected, and they will turn on our light. And our devices, of course, will have its own grounding screw. Our single pole switch usually will have an on and an off. So I want you to show me how you would wire this so that the power comes in first to the receptacle, then goes into the switch, and then it turns on the light. Alright?
Yeah.
Any questions? Is it clear?
Yeah, clear.
Yeah? Okay.
So,
No.